Welcome to eTree's Enhancements. Today we are actually visiting something that is missed, and I haven't really found too much information on it, so bear with me. It might be something that could be considered bad, but I have found it to be nothing but great. This issue didn't seem too common on Gen 3 models, mainly because of the geometry of the trigger bar itself. All right, hold up. Now, before we get too far into the video, I do have to say a few things. Number one, this isn't necessary. If your Glock is functioning perfectly fine, there is no need to do this. You can see if you might benefit from it. There's a few ways of telling if that's the case or not. And one of them would be if you replace the connector and you end up in a situation where no matter what connector you put in it, you end up with the same trigger pull. Or if you notice this scratch right here. There is a little scratch right there. Goes forward, front to back. It doesn't appear like anything crazy. Alright, here goes my best attempt at trying to show you the actual scuff mark, which is almost parallel with the sear sticking out towards the rear. There it is, really zoomed in up close where you can, I guess, fully see it. But what that is, actually, the slide itself. This part right here. That is what pushes the connector side to side whenever it basically moves it out of the way. It's what forces your reset. As soon as the slide comes back, it'll force the reset of the striker and the trigger bar. So that's what this does. However, it was causing the trigger bar being so far up as it was causing contact with it when it shouldn't be. And the best way to tell that it's no longer going to happen is, at least as soon as we're done modifying it, is your trigger bar should be flush or close to flush with this little ledge right here. But it is worth noting that if it does sit any higher than that, more than likely it will be impacting against it, which means it's going to be hindering your trigger pull, because now you're also going to be grinding away at it instead of having smoother trigger pulls. Now, it might eventually break all the way through and grind itself to a point where it's no longer making contact, but it's still not good, because chances are you could have a way better trigger just by solving this issue. So if you notice the handgun looks a little bit different, that's because I've made some changes since I made the video. I moved from the Olight to the TLR7A. You will be seeing the majority of the time of the Olight, and I've got some AmeriGlow fiber optic front, which are like $40 sights, which is why I went with it. I'm trying to go a little bit cheaper on this, but yeah, that's about it, except for the TLR7A. That's not the cheapest light there is available, but I love it. So anyway, let's continue with the video. Now, this video is going to be information heavy, so if you don't know how a Glock works on the inside, this video does not pertain to you. It's just a wealth of information as far as different generations of Glocks, so if you aren't that kind of person, then just go ahead and skip. If you'd like to just go to something else. But this is something that is worth checking into, because it could actually change the way that your trigger performs. Now, this isn't necessary at all. Like, if your gun is functioning perfectly, this is not a problem to really have to solve. It's something that might improve your trigger by perfecting the trigger geometry. Now, right here I have a few trigger housings and a trigger bar. I have a Gen 4 trigger bar that's been modified because I was experimenting on it. A Gen 5 trigger bar and a Gen 5 trigger housing and a Gen 4 trigger housing. Sorry. Anyway, moving on. So the first thing that I'm going to show you is Gen 4s, out of all of them, even Johnny Glocks mentions this, Gen 4 trigger bars, he uses them to get a crisper trigger pull because they have a different rounded section right here. These little curves right there, it's hard to tell, but the Gen 4, which is on my left hand, is a little, I guess you could call it bumpier, a little bit fatter of a curve. So anyway, moving forward, so what that does is it actually gives you a slightly crisper trigger, but not getting too deep into it, I've actually got a little connector here, and I've got the Gen 4 trigger bar. So using the Gen 4 trigger bar, you would come in and you would see the geometry, and then you'd pull the trigger, this would come back and then impact that surface, right? Relatively simple to explain. Well, with the Gen 5s, it puts that impact point a little bit lower, so it rides the lower portion of the ramp right there. Now, this was an issue that I bumped into with a Gen 4 Glock, another Glock I've got, where I had all original internals. It was a Gen 4 connector, a dot connector, the Gen 4 trigger bar, and you would pull the trigger and it was like 5.56 pounds. And I was like, you know what, I want a lower trigger pull. So I installed a Zev Pro connector, and I actually ran into some issues in the sense that the Zev Pro connector was actually giving me the same exact trigger pull as the dot connector, which doesn't make any sense at all, because the ramp angle, this angle, is not as steep, so it should technically roll off of it a lot easier, therefore lighter trigger pull. So what I ended up finding was that the trigger itself, this angle, now keep in mind this is a damaged one, I've modified it, so just ignore it, but this still fits into it. This angle right here, this 90-degree angle, plays a huge role in how your trigger pull is actually going to be. If this isn't at a perfect 90-degree angle, and let's say this is more of an, I think the word is an acute angle, where it's smaller than 90 degrees, let's say it's an 85 or 80, it will actually cause this little ramp to sit higher than where it should. So what'll happen is it'll sit so high that no matter what kind of connector you've got, it'll actually impact the corner instead of hitting the ramp. And then no matter what trigger pull you have, it'll always have the same amount of force required to break past that. So you end up with a really heavy trigger pull no matter what connector you're running. Unless you're running something like a, I don't know, like a ghost setup, which is kind of, I really don't want to get into those. They're kind of weird. But I found that there's no real crazy way to fix this, because the only thing that keeps this trigger bar from coming up is this right here. So it's already trying to pull up with the spring, but then the only thing that really stops it from going any further is this little notch right here. So there's going to be some play, but what you end up finding is that when you start pulling the trigger, you'll pull it and then it'll hit right here, and then you'll see this whole thing twist as it's trying to make its way past. It'll do this. Let me see if I can get a better twist, and then it'll go down. So it'll twist first, and that just throws the whole trigger pull out in the wild as to what it could potentially be. Instead of being nice and smooth or nice and crisp or just consistent in general, it just throws everything out. Not to mention there's a few other issues which I'll show you, which this Glock, this one actually shows a different kind of error. So number one, looking at it just as it is, this is a modified back plate that I cut off just to be able to inspect the sear engagement. So there you can see, you actually can't even see the sear itself. The trigger bar is actually underneath it, which means this thing has 100% engagement. So this thing's actually extremely safe. There's nothing that's going to cause this thing to fire now. This thing's already a little bit torn apart, as you can see, but what I've wanted to show you is this specifically. So let's pull it forward just so it's easier to see. Right, you can see a little scuff mark right here. That's the other issue that you'll get into when you start rocking and whenever your geometry is not exactly where it should be. So these are stampings. This is known as a common problem with stampings. They're not consistent. They're not perfect. The Glock is never really made to be like a 1911 where it's all precise. They are precision instruments as far as what the slide goes into, but you can't really get too perfect with stampings and polymer. It is possible, but not for mass-produced items like these Glocks. But anyway, moving on. So what we're going to try and do, and I'll actually show you the rocking motion, so you can kind of see it rock. It might look like it's going down, but it's actually rocking in place. Man, this is so hard to show. But anyway, the only real way to solve this problem is by making this angle larger than 90 degrees. So if over here is 0 and this is 90, if this angle is 0 and this is 90, we want to go a little bit higher. So what that'll do is it'll actually force this section of the trigger bar right against the trigger housing, and this to the bottom of the trigger, technically the top of the trigger housing, but force it down, and then it'll force this side up. It'll keep everything a little bit more consistent. So we'll go ahead and pull it apart. And try to pull this apart for now. So what we're trying to eliminate is this rocking motion. It'll force everything down, it'll lay flat, and there's still a little bit of room to play. So what we're essentially doing is we're putting the vise, basically one side of the vise, I'm gonna act like these are the jaws. You're gonna clamp it down like this, and this will make the angle greater, but you can only go a little bit at a time. So I can't really show this on video, but you'll get the idea. I'm actually putting one of them on the edge. I'll throw in a screenshot of how it's supposed to be. All right, so here you can actually see how it's supposed to be placed. You can see that one side of it's actually dangling out, and that is primarily so that it can actually let it whenever it does flex in, those edges will want to spread out. If you try to do it just against the vise, it's actually not even going to move. You're just going to potentially crush it. So you need to leave one end out so it can actually spread. Now, please make sure to do very, very, very minute and small adjustments, because a little bit goes a long way with this, and you might end up having to redo it again like I did, which you will see in the video. Now, keep in mind that I am not liable for you destroying your own handgun. Modify at your own risk. This is my personal firearm. If I destroy it, I get to pay for the repairs, and if it doesn't work, then it's my own fault. So if you do this, it's all on you. I'm just showing you what I did, so keep that in mind before you try and modify anything. Because these are fairly brittle too, so I just did that to this. It's a little bit. And again, it's super fast. Let's see what kind of effects I'll end up with results. And let's see where we're at. Still rocking a little bit. Which again, it's not that big of a deal, but it really shouldn't be there. It's not going to cause any problems if you have it. It's just not going to be the best trigger pull you can have. It's really all it is. If your gun's firing, you don't need to do this. This is just me being me, I guess, a quote-unquote perfectionist. So now it might have been a little bit too much, but it seems to be accepting it quite well. So now the wall isn't as hard, and instead it's a really smooth setup, but it's too far now. So let's take this bitch apart. This guy right here is scraping against the inside of the trigger housing. So now, about the only thing I can do to fix this is pinch it right here, from here to here. Alright, so in the video you might have seen that I accidentally went a little too far. So in order for us to correct that issue, we're actually going to have to clamp it down in this position specifically. This is the trigger bar on the vise, and then here it is zoomed in. So you get a better picture of exactly what I'm doing. Now, you have to do it tiny amounts, like thousandths of an inch, super small. Do not crank it down. This is like bit at bit, and just put it back in and see what happens. Again, I'm not liable for you destroying your own firearm doing this. It's a fragile part, so be careful. Let's see where we're at. Okay, that seems to be pretty good. Hopefully I didn't go too far this time. Alright, so it's done. The new setup actually solved a few of the problems. That is, the actual trigger bar from hitting the ledge instead of just following the ramp. Last inspection to be done would be make sure that you have good sear engagement, which in this case we still have 100%. There is one small side effect of doing this, and that is you will actually shorten your reset and shorten your post travel, because it moves the hump itself a little bit lower from the original position. So because this thing sits a little bit lower now, it'll actually move a little bit farther before it makes contact. It's just the nature of it. This gun is no longer scratching against the slide on the top, as it should not be. It is now as it should and was intended to be. And now it makes use of the ZEV Pro connector to the point where we get, depending on where you put your trigger pull gauge, kind of try to get it right there. I'm right at 4.5 pounds, which is where my other Glock is. My other Glock has a lot more rounds through it, so it's a lot smoother. I actually did have to take a 1200 sandpaper, and I don't usually go too crazy. I just knock off the anything that's kind of like protruding, anything sharp. I'll knock those edges off, and I'll always go in the direction of travel as to not affect the, basically if the piece is sliding this way, rubbing like this, then I'll take the sandpaper and rub in the same direction of travel. That way it's unaffected by it. If I sand in this direction and then this travels in this direction, you'll feel the grittiness. Yeah, I'll just wait for the gun to break in itself after that. It'll polish itself anyway for whatever it's worth. And now the trigger, is as I like it, which is firm wall, but still super slight rolling brake. Whereas before you'd press on it, and if you try to do it slowly to where it's a rolling brake, it would just break through. But if you do it fast, it's still just a hard wall. That's kind of what I like. Semi-hard wall, which is, it'll break fast enough if you want it to, but it'll still roll into it if you want it to roll through. Now this one still has that super slight grittiness, not compared to my other Glock, but that has solved the problem altogether. It still rocks a little bit, but the little ball right here, which I actually coincidentally ground off on this one, will prevent it from rotating too much. So yeah, that's about it. I mean, there's nothing crazy to this mod. It actually does improve the trigger pull by a lot. It brought both of my trigger pulls right where they should be. They don't twist anymore. They don't do anything crazy. They don't hit the edge of it. They actually follow the ramp as it should. This issue is probably not very prevalent in Gen 3 trigger bars because they have a smaller radius bump, so that means they can actually bypass that ledge a lot easier. At least that's what I've found in the Gen 3 guns that I've had. I've never ever had to figure this part out. But the Gen 4s, both of them, whenever I put a different connector on them, they both hit the ledge. At least on the Zev Pro connector. I don't know if this is just the Zev Pro thing or whatnot, but this is what I had to do to fix it, and I think it is an actual fix considering it was actually rubbing up against the slide, so yeah, I don't know how to feel about that. This is just a bit of information that's helped for me on the Gen 4 Glocks. If this works for you, awesome. If it doesn't, then carry on. Yeah, hope you guys like it. Go ahead and subscribe if you'd like to see more content. Thank you.